Welcome to SPSS Algorithms Introduction. In the following, I will take some time to introduce the generalized linear regression in SPSS. Here is the agenda of today's introduction. First is the overview of generalized linear regression, including a brief introduction of the algorithms and what's the main feature provided by SPSS generalized linear engine. Then, I will bring a use case to demonstrate how to leverage generalized linear regression to solve real business problems. Then, at last, with the case, a demo will be presented to show how to use SPSS generalized linear regression in IBM products. Before introducing generalized linear regression, let's have a brief look back of linear regression. This is the general expression of linear regression model, where y is the target variable, also known as dependent variable. X represents the predictors, also called interdependent variable. Beta is called regression coefficient, and epsilon represents the residues of the model. In regression analysis, if only one predictor and one target are included, and the relationship between the two can be expressed by a straight line. This regression analysis is called universal linear regression. If the regression analysis includes more than two predictors, and the relationship between the target and the predictors is linear, it is called multiple linear regression analysis. There are some assumptions for linear regression. First is the target need to be measured at the continuous level. Then the second is there need to be a linear relationship between target and the predictors. The third is all variables or the residues of the model should follow normal distribution. Also, there should no significant outliers in records, which is breaking the linear relationship. But in data analytic world, there are many situations don't follow this assumption, so generalized linear model is proposed. In data analysis, generalized linear model is a widely applied and more practical regression model based on the general linear regression. The target variable can be discrete or continuous. Compared with general linear regression model, there are the following advantages. First, the target variable can be either discrete or continuous, and the distribution of the target can be non-normal. For example, a researcher is interested to predict consumers' choice for one of three products. In this case, the dependent variable can only take one of the three category values, and the distribution of the target is said to be multinomial distribution. Second, the dependent variable doesn't have linear relationship with predictors, like the red plot shows. The generalized linear model can be used to predict responses for discrete distributions, and for target variable which are non-linearly related to the predictors. SPSS generalized linear engine bases on generalized linear regression algorithms, covering a widely used regression models, which is used to analyze continuous data or the discrete data in a unified statistical framework, such as linear regression and logistic regression. The model consists of three components. First, a distribution from the exponential family. Second, a set of predictors. Third, a link function. The distribution of target is extended to normal distribution, Poisson distribution, gamma distribution, inverse Gaussian distribution, and so on. A link function will be used for a target variable to build up the generalized linear model. In particular, when the link function is identity and the distribution is normal, generalized linear regression model is a linear regression model. From this page, we can see GLE supports 9 distribution and 16 link functions. All of them are listed on this page. For the non-distributions here, first, normal, inverse Gaussian, gamma are used for numerical target with real type values. Then, boson, negative binomial are suitable for numerical target with integer type values. Then the binomial, ordinal multinomial, and the normal multinomial are suitable for the categorical target. 3D is a mixed distribution which can be applied for both continuous and categorical target. Also, from this table, we can see that the combination of the distribution and the function is not a random combination, and different distributions corresponding to specific link function sets. This requires that the analyst choose suitable distribution and link function for their specific problems. SPSS GLE algorithms is developed from SPSS GLE procedure, with additionally supporting model selection, predict two-way interaction detection, and big data capabilities in distributed environment, such as Hadoop and Spark. GLE is a unified statistical framework, which covers some corresponding procedures in SPSS statics shown in the table. For example, GLE binomial distribution with logit link function is a logistic regression model. For the non-distributions and the searching link functions in GLE, how user to select combination of them tend to be a question. For experienced user, he can select proper distribution by understanding of data and the measurement level of the target. If the target is continuous, the user can use all distribution except nominal and ordinal. But in the target is flag, only binomial is applicable. For the function, he can select a proper one based on his understanding of the relationship between the target and predictors. For the beginner user, GLE also provides the features of distribution link function auto selection to help user select a proper distribution link function combination for the given data. To prevent overfitting, SPSS GLE also supports lasso, ridge, elastic net regularization methods. Lasso is also known as L1 regularization, which can also be used for predictors selection. Ridge is known as L2 regularization. The method prevents overfitting by shrinking under parameters. It is shrinking all parameters by the same proper proportion, so it is not a variable selection method. Then elastic net, also known as L1 plus L2 regularization. It performs both variable selection and prevents overfitting by shrinking under parameters. This page shows how SPSS GLE used for big data. First is leverage analytics server platform, which is a predictive analytics platform using Hadoop and Spark capabilities. Second is that we implemented standard Spark ML API for GLE and can run GLE in Spark environment directly. Then next is a case to demonstrate how to use GLE to solve real business problems. Eric is a bank officer who has some historical data with 700 customers given loans before. From the data, he wants to identify the profile of the people who are likely to default on loans and then use those profiles to identify good and bad critical risks. He wants to build a logistic regression model to advance whether default loan to new incoming customers. Let's go through the data briefly. The data includes some customer characteristics such as age, level of application, and the last column default represents whether default on loan before. 1 means yes and 0 means no. Eric will use the default field as target and other fields as the predictors to build a logistic regression model by GLE. The distribution type, select binomial, and the link function, select logit. After Eric built the model, he finally gets a series of output. From output results, Eric can see some basic information, including the classification accuracy of the model and some model fitting information, such as the ASC and PSC. The accuracy of the model is about 82%, and we can also see the predictor importance value for each predictor. The type threes are years in current employer, debt to income ratio, years and current address. By the model, we can predict the rates of loan default for new users. Well, in next step, I will show how to use GLE in IBM product. First demo is in the SPSS modular, and the second one will be in IBM PSX with notebook. Okay, this is the IBM SPSS modular. With SPSS modular, you can build predictive models quickly and intuitively, without programming. Using the Unicode visual interface, you can easily visualize the data mining process. This is the stream to analyze Eric's data, including a model building branch and a prediction branch. We use a data source node to load the data, and by our output node, we can see the records in the data. Click run here. From data, we can see the first 700 records is the data for model building, and for the latter 150 records, we can see the target value is all missing for now, so they are the data Eric wants to predict. Then we can use a tab node to get the metadata information for each field. Open the tab node. You can see that. We can see the measurement level for each field and the values for each field, and also the row definitions for each field. Here we select default as the target. Then we use the select node to select out the records whose target value are not known for model building. We define a rule here. After select node, we connect a GLE algorithms node to configure the model building settings. Open the node, we can see the detailed configuration of the model. We set the target as default and select the distribution and link function combination as a binary logistic regression. Then in the model effects tab, we set the effect from the input predictors. Now, here we only include main effect here. There are also other detailed model configurations, such as the estimation and the model selection methods. For the experienced user, he can select what he wants. But for the beginner user, he can leave them as default values. After the configuration, user clicks Run to build the model. Then the nugget is generated. Double-click the nugget, we can get the detailed model information. For example, the model information, the record summary, and the test of model effects, and also some predicted importance values. And with the nugget, Eric can predict the incoming customer data. In this stream, Eric selects the records whose target value is known, and he wants to predict those target values. From the table node, we collect the run and get the prediction result. We can see the predicted values here and also the probabilities here. Okay, this is demo for the SPSS modular. This is a demo in IBM Data Science Experience. Data Science Experience, also called DSX, provides users with the environment and tools to solve the business problems by collaboratively analyzing data. Here we use the DSX on public cloud. This is a notebook in DSX, and here we use the Scala 2.11 with Spark 2.0 kernel. DSX also provides other kernels here. We can see here also provided the Python and R with different Spark versions. When starting a DSX notebook instance, the DSX programs will be preloaded, and we can write code to invoke GLE. The first step is to get the project token for GLE model variations usage. Then, next is to load the data and create Spark data frame. This piece of code can be generated automatically. In the right, user can select the operations for the data and collect the insert Spark session data frame. Then the code will be generated. After run this cell, we can see the data frame is created. Before building GLE model, we can invoke SPSS enrich method to enrich the metadata info in the data frame schema. We can compare the metadata info in the data frame schema before enrich and after enrich. After enrich, we can see each field has much more information, such as the story type, min-max values for the continuous field, and the categorical levels for categorical field. With the updated data frame, we can write code to invoke GLE and configure the settings. Then use the fit method to build the model. After model is building, we can finally use the model viewer package to show the model in table and plots. Here we will use the project token just we mentioned. Okay, here is the model viewer for the GLE model. It includes the model evaluation, model information, record summary, and the test of model effects, and other confusion metrics and ROC curves. Okay, that's all for today's introduction. Thank you very much.